And welcome students as we continue to talk about programming with arrays. Today we're going to take a little bit of a segue and we're going to discuss what is known as the for each loop. So getting started, as we have already seen, we can use a for loop to cycle through all the elements in an array, whether it's filling the array, outputting the array, doing an operation with the array. This is what we've been using. So here's a quick example, just kind of gives a recap. Double array A equals new double 10. We have some code to fill the array. And then for int I equals 0, I is less than 8 at length, I plus plus, system out print line, array of index I. So it's just outputting whatever the element is at that value. Now let's talk about collection classes. The standard Java libraries contain definition of a number of so-called collection classes. A collection class is a class whose objects store a collection of values. It kind of makes sense. Now, you cannot cycle through all the elements of a collection object with this kind of for loop, the kind that we just showed on the previous page, because these collection classes normally do not have indices associated with their elements as an array does. However, in this newest version of Java 5.0, Java added a new kind of for loop that can cycle through all the elements in a collection even though there are no indices for the elements as there are an array. So pretty much with everything that we're going to be doing with, it's Java 5.0. So there is a way you can cycle through everything, and that's with the for each loop. So this loop, as I mentioned, is the for each loop, or it's sometimes known as a enhanced for loop. And we'll discuss it in a later course, I believe it's Programming 3, in much more detail about for each loops. All right. However, these new for each loops can be used with arrays as well as objects of these collection classes. So even though we're not going to be dealing with collection classes today, we're still going to be working with arrays, and we can touch a little bit with the for each loop to kind of give you your first introduction. Now, we're not going to expect you to have for each memorized or down pat at this point, but you should be familiar with it and how it can be applied to an array. So in this lesson, we're going to use for each loops with arrays in case that you did want to start using a for each loop. So the following code ends with a for each loop that is equivalent to the regular for loop we gave at the start subsection. Double array A equals new double 10, some colon fill array, for double element colon A, system out.println element. You'll notice that it's very similar, but at the same time, the for conditions are slightly different. Now you can read the line beginning with for as for each element in A, do the following. You'll note that the variable element has the same number of type as the elements in the array. So both are of type double. If we look back, the array was a double array, and the element was a double type as well. So it's very important that those match. The variable like element must also be declared in the for each loop as we have done. And if you attempt to declare element before the for each loop, you're going to get a compiler error message. So it has to be a localized variable to that loop when you're using for each. All right. Now the general syntax for a for each loop statement used with an array is the following: for array base type, so whether it's int, char, double, whatever, the name of your variable, colon, array name, and then whatever statement you're going to have it do, whether it's just a print line statement or something else. Now be sure that you notice that you use a colon, not a semicolon, after the variable. This is a very important distinction because up to this point we haven't really done anything with a colon. It's always been with curly brackets, semicolons, and now with starting arrays, braces. But now we are getting into using a colon in this example here. Now you may use any legal variable name for the variable. You do not have to use element. So even though in the example I gave element, it's just like any other variable. You can call it whatever. You could call it number. That would be fine. You could call it array value. You could call it turtlefish. It doesn't really matter as long as you are using a logical name. Now, of course, our names of variable conventions should still apply, should still be something that's relevant to what you're working on. So something like turtlefish probably wouldn't be as appropriate for our program. Now, although it's not required, the statement typically requires the value. So if you're doing system.println, you notice in the example we gave you a system.println element. All right, so the variable is included in that statement. But you may not necessarily need depending upon what your loop is doing. Now, when the for each loop is executed, the statement is executed once for each element of the array, which means that if you have 5 elements of the array, it's going to go through the loop 5 times. More specifically, for each element of the array, the variable is set to the array element, and then the statement is executed. The for each loop can make your code a lot cleaner and also a lot less error prone. Because if you notice, compare that to a normal for loop. Normal for loop has 3 statements. You typically have your initialization statement, you'll have your comparison statement, or your end statement if you want to think about it that way, and you'll have your increment or decrement statement. If you're not using the index variable in a for loop for anything other than a way to cycle through all the array elements, then a for each loop can actually be preferable to how we've been doing it before. So here's a quick example. So for double element A, and we're just saying sum plus equals element. So what you're doing is you're taking sum and you're adding that to element. We're not worried about the sum because it's probably just an integer declared outside, or in this case it would have to be a double because we have a double array. So it's just a double sum, and each time it goes through the loop, it's just adding element into that sum. So it's adding up the sum of all the elements in the array. So then we look at the other way, which is how we would normally do this. For int I equals 0, I is less than a.length, I plus plus, sum plus equals array of I. Right. You'll notice that this is a lot cleaner in presentation than the second way. Now, if you're not comfortable doing it the second method, or excuse me, the first method, you're more comfortable with doing it how we've been doing, that's perfectly fine. There's nothing that says you have to do it this way. It's just another way that you can do how you can cycle through your arrays. Now, the 2 loops, as I mentioned, will do the same thing. But the second one mentions an index I that is not used for anything other than enumerating the array elements. Also, the syntax for the for each loop is simpler than that of the regular for loop. On the other hand, if we look at the following for loop, we want to leave that as is and not attempt to convert it to a for each loop. For int I equals 0, I is less than a.length, I plus plus, a of I is equal to 2 times I. And the reason why we want to do that is because this loop uses the index I in the body of the for loop and uses it as an essential way. It does not make sense to convert this to a for each loop. Because if we look at this previous example, you'll see that here we have sum is plus equal to a of I. So just using I as a reference point. If we look at this one, I is actually being used in the calculations. So we don't want to actually kind of convert that over. Okay. And that's going to wrap up our notes for today, folks. So hopefully you get a new type of loop under your belt, and we'll see you next time.